Welcome back to CIT 157 Module 6-2. In this module, I want to talk about IP address. At the end of this class, you will be able to recognize IP addressing including class A, B, C, network address, host address, and network mask. Read Business Data Communications and Networking CH5 Network and Transport Layer, and Networking Essentials CH6 TCP/IP. Prerequisite is, you should know how to convert binary number to decimal. For example, 01000001 in binary is 65 in decimal. Activity 1 Devices hub, switch, and router. In a network, each node should have some unique name, IP address, to communicate each other. Inside a network, computers use MAC address to communicate each other. Hubs only connect computers together. Switches not only connect computer together but also reduce traffics of the signal using MAC address. So switches are called smart hub. However, the prices of switches are not expensive. So people use switches to connect computers. If you have different network, you need a special device router to forward your network signal to other networks. If signal's destination is inside the network, the router will stop signals going to other network. If routers do not stop signals of which destination is inside the network, internet would be too crowded. To make above jobs easy, routers use a network address. This is what I have explained from previous slide. This is an example designing network at a university using switches and routers. Now let's talk more about IPv4. An IP address is an address, name, used in order to uniquely identify a device on an IP network. The address is made up of 32 binary bits, which can be divisible into a network portion and host portion with the help of a subnet mask. The 32 binary bits are broken into 4 octets. 1 octet equals 8 bits. Each octet is converted to decimal and separated by a period, dot. For this reason, an IP address is said to be expressed in dotted decimal format, for example, 172.16.81.100. The value in each octet ranges from 00000000 to 11111111 in binary, 0 to 255 in decimal. Devices use binary number originally. However, we convert it to decimal so that human users can recognize it easily. You need to know these terms. Each network portion, in a same network, should be the same number. However, each host portion should be unique in a same network. IP address is the combination of net portion and host portion. You can find net portion or host portion using network IP address and network mask. You can easily find network portion because it is same number inside a network by looking at several IP addresses in the network. However, you can use network, subnet, mask to find it. Align an IP address and network mask and multiply them each bit. And logic, 1 and 1 is 1, 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0. Then the result is network address, network portion plus 0 in all the rest bits. Using network IP address and network mask, you can easily find out if an IP address is belong to a certain network or not. For example, suppose a network that has a network address 8.0.0.0 with net mask 255.0.0.0. First you need convert net mask to binary. Then it is 1111111.000000000000000000000. These ones indicates the common parts among all individual host IP addresses. Then any IP address start with first 8 is belong to this network. If a destination IP of a signal is 7.0.0.4, then it is outside signal because network portion of IP address is different from 8. So the router will forward the signal to next network. Activity 3. Classful IP address. There are 5 different classes of networks, A to E. In Class A address, the first octet is the network portion and the rest 3 octets are host portion. In Class B address, the first 2 octets are the network portion and the rest 2 octets are host portion. In Class C address, the first 3 octets are the network portion and the last octet is host portion. Class D address is for multicast. Class E address is for experimental and reserved for the future. For IP address, there are natural network mask for each class. Class A natural network mask is 255.0.0.0. Class B natural network mask is 255. 255.0.0. Class C natural network mask is 255. 255.0. Without specific information, these default network mask for each class. Let's see each class in more detail from next slide. Major Class A network address range is between 1.0.0.0 and 127.255.255.255. Its default natural masks is 255.0.0.0. It means the first octet, 8 bits, is for the network portion, and octets 2, 3, and 4, 24 bits, are for the network manager to divide into subnets and hosts. A major Class B network address range is between 128.0.0.0 and 191.255.255.255. Its default natural masks is 255.255.0.0. It means the 2 octets, 16 bits, are for the network portion, and octets 3, and 4, 16 bits, are for the network manager to divide into subnets and hosts. You may have up to about 6,500 useful hosts. A major Class C network address range is between 192.0.0.0 and 233.255.255.255. Its default natural masks is 255.255.0.0. It means the 3 octets, 24 bits, are for the network portion, and octets 4, 8 bits, is for the network manager to divide into subnets and hosts. You may have up to about 254 useful hosts. Practice this with paper and pencil. This is the answer. I will talk about broadcast IP address soon. Activity 4 useful, available, IP address, network address, broadcast address. A network address represents a range of IP addresses. A network address is the first IP address of the range. Broadcast is the last IP address of the network. Think about a Class C IP address 204.17.5.1. Since it is Class C, network mask is 255.255.255.0. Then the net portion is 204.17.5. And host portion is 1. Network address is the first IP address in a network. Now by the definition of network, there should be more computers connected in the network. Net portion is the same in a network. So it is always 204.17.5. Inside this network. Then, you should only deal with host portion, which is the last octet. In the last octet, in 8 bits, how many numbers can you have? The range is 00000000 to 111111111 in binary and 0 to 255 in decimal. Then, in this group, what would be the first number? Of course it is 0. So first IP address is 204.17.5.1.0. Now as I have mentioned in the beginning, the first IP address is the network address. Network address represents whole network as a group. So you cannot assign this address to a computer. What is the first useful, or available, IP address for a computer? It is 1. So first useful or available IP address in the network is 204.17.5.1. The second available IP is 204.17.5.2. What is the last host portion of the network? It is 11111111 in binary or 255 in decimal. By the way, we use this last address in a network as broadcast address. Broadcast means when a computer sends message to every computer inside the network, we use broadcast address. So we cannot assign this IP address to a computer. Then the last useful or available IP address is 204.17.5.254. Practice this with paper and pencil. This is the answer. This is the end of module 6_2. You have learned some connection devices, hubs, switches, and routers. You also have learned about classful IP address, net portion, host portion, network address, broadcast address, and useful IP address. I will see you in next lecture.